Thomas Rintoul.
Et superte.
So, I've graduated with a Master's in Physics and Astrophysics from the University of St Andrews. Let's have a look back. Hey everyone, welcome to the video. My name is Thomas Rintoul, and if this is your first time coming here, then hello, welcome. If you've been here for the majority of my degree, then welcome back. For the last 3 years, this channel has had a lot of academic content on it, with me studying for my astrophysics degree at St Andrews, and now that's over. This is going to be mostly a talking head video. It's going to be quite long, so please feel free to minimize the video, just listen along. There's not going to be that much happening on the screen other than me talking at the camera. It's the full review, everything start to finish from before the channel started, so like first year and second year, all the way through to the end of my master's year. I'm going to talk about academics, the social side, and some of the challenges of being at St Andrews, some of the challenges that go along with this university. Also, yeah, I'm no longer in St Andrews. I've moved back to my mom's house. This is my bedroom at home. Let's get into this. So the video is going to be split into 5 sections. These are going to be looking at sort of the pre-St Andrews phase, things that happened before I actually arrived, so applications and such. Then I'm going to review each year in turn, talking about each module that I sat, the overall feel of the year, how each year went. I'm not going to go in detail on my grades. I will do some, but not many. But yeah, the reviewing each year in turn is probably going to be the longest section of the video. Then I'm going to look at the social side, the extracurriculars, things that happened outside of the classroom. Then I'm going to finish off the video by reflecting on the challenges and then finally summarizing everything, the whole experience. There will be chapters along the bottom of the screen here for you to follow along with, to jump to any sections you're interested in. I appreciate long video, it's going to be needed. So let's get started. Let's talk about everything before uni. So the background, the before uni, the before times. St Andrews has always been my favorite place in the world. It is it's a place that I can't honestly remember a time where I didn't know St Andrews. I didn't love the town. Been going on caravan holidays there for years. We went a couple of weekends every year. My mum had done her English Lit degree there, graduating back in 1989. After a long time of reading and writing in school, I was honestly convinced I was also going to do an English degree. Then we got to high school, and my third year English teacher basically said the only thing you can directly do with an English degree is teach, and that suddenly dissuaded me from doing an English degree. So that was dead in the water. Around the same time, I also had a really good physics teacher called Mr. McKellen. He told me about astrophysics degrees existing. Before this point, I didn't know that it was a thing you could do at university. I have always loved space. I'm a massive Star Trek fan, always have been, and honestly, to be able to study the physics of space and what goes on there just sounded perfect. So I looked into it and found that, there were 4 universities in Scotland that did astrophysics degrees. 3 of them did a master's. So the 3 that did masters, integrated masters, so that's a 5-year degree straight to postgrad. I only looked in Scotland because, Scottish, free tuition, it's great. So came around to UCAS application time. 5 applications, 3 of them went to the 3 unis that did integrated masters in astrophysics, which are St Andrews, Glasgow and Edinburgh. I then also applied to the BSc course in astrophysics at Dundee, and because I needed a 5th choice, I applied for a master's in physics in just physics at Strathclyde. I didn't think I'd need it. I had good higher grades, but I needed to fill out all 5 choices. Suffice to say, I got my pick of the bunch. All 5 unis came back with unconditional offers. I had free reign. So automatically, Dundee and Strathclyde out of the mix, either not the right course or not an integrated masters. That left the 3 older universities, Glasgow, Edinburgh and St Andrews. Edinburgh rubbed me up the wrong way on the open day. I don't know, I had this just overwhelming feeling that they didn't want somebody that sounded like me, that somebody that had gone to a bottom half Scottish state school. I just felt out of place. Yeah, I didn't like Edinburgh. So that left Glasgow and St Andrews. I went to the Glasgow Open Day, really liked it, and actually for a long time, St Andrews and Glasgow were neck and neck. I could not pick. That lasted about 3 hours at the St Andrews Open Day. I don't really know what it was that made the choice for me. I don't know if it was the fact that it was more open, more friendly, that everyone was so enthusiastic about it, students and staff. I don't know if it was the fact that I knew St Andrews pretty well already, or it could have been a combination of all of them. It just kind of felt right. It was a gut feeling, and it was a gut feeling that was correct. St Andrews has been great. It was definitely the right choice for me. Fast forward a few months, we get to February, my offer comes through, it's unconditional, and I accepted it within 6 hours. So I was going to St Andrews. Come around to September, I'm moving into University Hall, one of the halls of residence in St Andrews, and I'm away to start my studies at university. First year at universities in Scotland, including St Andrews, is a bit of an oddity in the UK. Most degrees in the UK that are like BScs or BAs, like the sort of typical undergrad degree, are 3 years, with integrated masters being 4 years. In Scotland, we have an extra year at the start, so BScs are 4 years long, and masters, integrated masters, are 5. This extra year is typically much broader. You do 2 or 3 subjects in your first year rather than immediately starting on the one you've applied for. I honestly think it's great. We specialise way later in Scotland, which leaves things broader, more open. It lets us change our mind, quite frankly. I took 6 modules in this first year, 2 compulsory physics modules, 1 compulsory maths module, and a compulsory astrophysics module. And then I had 2 optional maths modules I took as well. So that makes 6 modules, all 20 credits each for 120 credits. So let's have a look at the modules I took in my first year. We'll start with the compulsory physics modules. These are modules that everybody doing a physics degree takes, though people can take them if they're not doing a physics degree. There's a few extra spaces. These are Physics 1A and Physics 1B. Physics 1A and 1B were largely a bit of a recap for me. Because I'd done advanced hires in my 6th year at high school, these go slightly beyond an A level in the rest of the UK. Because I've done these, a lot of the content in Physics 1A and 1B was stuff I'd seen before. The difference was that I was learning a new way to learn. Lectures at university are different from a class in school. Your tutorials are more discussion based rather than do some problems in class and get them marked. You've got practical work in labs to a degree that you don't really see in school, at least not in my school. This was a fairly gentle introduction to university though. It was gentle for somebody who'd done advanced higher physics, who'd done physics in high school. My lecturers were honestly really good. Something that is so criminally underrated is the value of a good teacher. One that values being able to teach well, not just to stand there and monologue at you for an hour. This is a general theme that you will find when I'm talking about the lecturers at St Andrews, at least in the physics department. Not everyone's brilliant, but most of them are really, really good, and it was something I was really lucky with when it comes to studying at St Andrews. The other big difference was the attitude to how teaching should work. At school, it was a lot about learning to teach for exams. We learned the stuff that was going to be on the exams so we could answer the questions and get the marks. They were teaching us more how to think, how to approach a problem, not just how to remember stuff and regurgitate it when it comes to exam time at the end of the semester. And this was something we saw from like the first week, the first semester of university. And that was really refreshing. Moving on to Physics 1B, we saw some additional new content, a bit more rotational mechanics, some quantum phenomena. It was stuff that hadn't really been looked at in school. Teaching was again fine, though there was one lecturer who I won't name. I'm not going to name anyone that I'm criticizing because I just think that's a bit mean. Her teaching style just wasn't really what worked for me. I think she was maybe just better at teaching older students who knew a bit more rather than first years who needed a bit more of a helping hand through stuff because we haven't learned a lot of the stuff yet. I think it just wasn't really explained that well for our level of physics knowledge at the time. The other big difference in Physics 1B is that there is a thing called the Group Discovery Project. It's a big group project. In my case, it was that we were given an assignment to find the optimum angle of a golf club, specifically a driver, for various different golf courses around the world, taking account things like atmosphere and variations in terms of like temperature with given seasons and altitude and all sorts. It was really interesting. We had to read a load of papers, read a load of books, and try and come up with a model, which we had to do in Excel because nobody in our group could code. As much as it was interesting, it was still a group project, and there were people in my group that didn't really pull their weight, and I ended up doing a lot of extra work to make sure that the thing was submitted on time. Group projects are kind of rubbish unless you get to choose your group, and you can choose people that are actually going to do the stuff. So yeah, group projects. So that's the core physics modules for first year. Let's talk about maths. This module, MT1002, is like the core mathematics module that anyone doing a physics degree or a maths degree or a few other science degrees has to have passed. It's taught by the maths department, and it was a lot of a recap of advanced higher maths, something that I had done. I don't have too much to say about maths, about MT1002, but it is the module where I potentially made the biggest mistake I have ever made at university. I slept through the class test. Yeah, that wasn't my finest moment. I have never groveled so much. Moving on from maths to Astro, the last of my compulsory modules for first year. The Astro 1 module at St Andrews is brilliant. It assumes bugger all knowledge. Like, you need to know, I think, a little bit of trigonometry, which is like National 5 GCSE level maths, and like, yeah, it assumes no knowledge of physics pretty much. It assumes pretty much no knowledge of maths, and it's a broad introduction to astronomy. You cover everything from the solar system to a little bit of cosmology, a little bit of the galaxy, a bit about how we observe the universe. So like, how do we know how far away stuff is? What do we know about the different planets, and why do we know this? Like, very broad introduction. We had lectures to learn the content, and then computational labs and tutorials to get into the stuff, to deal with some data, to really pick apart these new concepts that we hadn't learned before. And yeah, it was really good. It was my first experience of doing any coding. Minimal coding, but some coding nonetheless. Honestly, I wish this course was available to folk in schools. It would very much be something you could do in school. Seriously, this course, roll it out to everywhere else. It would be brilliant. If you need to fill a slot at St Andrews, take Astro 1, it's really good, you won't regret it. So after those 4 modules, I've got another 2 slots that I can fill in my first year, and those were filled by 2 optional maths modules. First one is an optional module called Pure and Applied Maths. It's considered one of the hardest modules in first year, and I think it's considered one of the hardest because of the fact it's a pure and applied maths module. Typically, people are good at one or the other. Physicists tend to lean more applied because applied maths is, you know, pretty much physics. Pure maths is, I don't like it. I wasn't very good at it, and that's why I failed the class test for this one. It's not the best module. It's fine if you want to do some maths. If you're not sure if you want to do some pure stuff, some applied stuff, if you're more pure-minded, then theoretical physics may be for you. But yeah, it was fine. I don't really have much more to say about that one. It wasn't the best choice. Neither, to be honest, was the next one that I took, which was MT 1007 Stats in Practice. And it was not that it was anything wrong with it. It wasn't hard. It was frankly really easy. The lectures were largely worked through the notes. The exam was... if you can do some basic problem solving and logical reasoning, and you can use a calculator and you can just remember stuff, this module is really easy. Me and my friends may have sat through some lectures making D&D character sheets, and then I left the exam half an hour early, having spent the previous half hour checking my answers, because I did the exam in an hour and still got like a first. It was not a hard module, it was just pretty boring. I'm not the biggest fan of stats. But yeah, that was my first year at St Andrews academically. I learned some new stuff. Mostly I learned how to learn at university, how to work more independently than you do at school. And to top it all off, I got the first year medal for astronomy, so I topped that module, which was pretty good. So pretty good on the whole. Moving on from first year, let's talk about second year. From here on out, if you want to know what the equivalent year is in the rest of the UK, just take one off it. In second year, I had all compulsory modules because of my degree. So I had 2 core physics modules. These are now 30 credit modules, not 20. I had a core astro module, which was another 30 credits, and then 2 compulsory maths modules at 15 credits apiece. Let's go through second year's modules. My core physics modules, Physics 2A and Physics 2B. Physics 2 just really builds on Physics 1, and it's where you can join in directly to second year if you've done like advanced hires or A-levels. It introduces a range of concepts you don't really see at school, things like thermal physics, more rotational mechanics, oscillations and waves, and the labs got a lot more interesting. We started being able to work more independently. You're given a lab script and you sort of work through that, and there's an element of you making your own choices. How many measurements are you going to make? How are you minimizing uncertainties, minimizing random noise? What is your experimental setup and why? And there's a bit more personal effort into that, as opposed to just following a list of instructions like we do in first year. The first year labs were more to give us a baseline set of lab skills, because everyone has a different set of lab stuff at school. Physics 2A, obviously more work than first year, but it's a bigger module. You'd expect that. Honestly, it was more interesting. We had new content, and yeah, I enjoyed it quite a bit. There was, however, one day that a lecturer did forget to show up to the lecture. It only happened once, and apparently it's only happened to him once in about 10 years, but that was quite funny. The other criticism that I would have of this module is that we use a system called Moodle. It's common at universities. It's like an online organization thing where you get all your course material. but there were so many like PDFs and other random files that we needed that it just filled up the Moodle page. It could have been better organized. I've seen it better organized. This one the organization was a little bit all over the place, but on the whole, good module. Physics 2B felt more like a preparation for going into honours level. So we focused on classical waves, they show up everywhere. Electricity and magnetism, you need to know the basics of that to then do the third year electromagnetism module. There was some quantum physics, giving us a sort of primer ahead of doing the more in detail quantum mechanics modules in third year. This module was more work. The stuff was a bit harder, more challenging, and it was mostly taught well. There was one lecturer that I didn't quite gel with his lecturing style, and I never have. I've had him for a few other modules, and I don't get the way that he lectures particularly well. It doesn't work for me. Works for some people, but not for me. This module was also one of the ones affected by COVID, because this was like start of 2020 was this semester. We lost our final lab. We did the written assignment rather than finishing off that lab. But on the whole, it was a pretty good preparatory module, and the uni handled the shift to COVID pretty well. I will cover COVID in detail later. The other thing that is really good about this module is that one of the assignments for the labs is a formal lab report. Now, a lot of people thinking, formal lab report, don't really want to do that. It's a bit rubbish. But honestly, it's one of the best things that could have been in this module, because I'd also found out about this thing called LaTeX. It's a typesetting software that is used everywhere in science, and I decided I've got a bit of extra time at the minute, just when it landed in the semester, I'm going to learn how to use LaTeX for this report, because it'll look way more professional, I was thinking. And it did. And this is kind of the start of me knowing how to use LaTeX, and it's a skill that's been really useful going forward for third year modules, fourth year modules, fifth year modules, my project at the end, and that's going to be really useful going forward into the future. So if you're doing this degree at St Andrews and you're doing that formal lab report, or if you're doing a similar thing at any other university, go and look online, find a LaTeX tutorial. I have one if you want to watch it. It'll be in the top right hand corner, and it's a really good typesetting software. Go and learn how to use it. Handles equations wonderfully, and it was not a requirement for this, but it's a great opportunity, and I'm glad I took it. So that covers the core physics. Let's talk about the core maths modules. There are two of them, 15 credits apiece, called Linear Mathematics and Multivariate Calculus. These are really important modules. They're kind of the basics of the physics that we need going into third year, and they give us a sort of mathematical basis for the degree. However, I have some criticisms of these modules. They're taught by the maths department, and they are part of the core 8 modules that maths students take in their second year. So they're designed for mathematicians. They're taken from a very maths-centric point of view rather than a more applied physics point of view, and I don't think that works well for physicists. I think that the physics department should take over teaching maths a bit sooner. The reason for this is I think the formalism in maths is less important for physicists. We're more interested in how to use it for something useful. I'll talk more about this soon, because we're going to talk about the third year maths for physicists module in a minute or two. But yeah, that's kind of my 2 cents on it, is I think that the physics department should take over teaching maths to physicists sooner. That being said, the modules were taught well, the lectures for them were really good, and I really love their lecturing styles. Just less so the content. So maths out of the way, let's talk about Astro. This was my favourite second year module of the lot. This is perhaps unsurprising. I was going to do an astrophysics degree. We got to go more in depth on a lot of the topics, really interesting topics that form like, again, it's a sort of broad look at astronomy, but going a bit more in depth. Things like exoplanets, observational techniques, stellar structure and evolution, galactic astronomy, all stuff that is really important going forwards. And honestly, it was really good, because the good thing about astronomy is that you don't need to have a really in-depth knowledge of everything for them to start talking about some of the interesting new science that's happening. You can start talking about things knowing some of the basic concepts, and then add more complexity to your understanding later. It's really good. Exoplanets was possibly one of the better sections of the course. They're really cool. I may not be an exoplanet astronomer, I'm very much not, but when you're in a second year lecture course and you're learning about how we detect exoplanets around other stars, and your lecturer is one of like the leads on the science team for the Cheops satellite, it's really cool. Stellar structure evolution was really interesting. We talked about a little bit about how stars formed. It was one of the first indications that I might be interested in star formation. And then we also had a look at galactic astronomy, which I found interesting, but it was, I don't know, it was taught from a fairly observational point of view, which I didn't like as much. I was just thinking, tell me about the objects, don't tell me so much about how we're observing them. This was maybe the first indication that I was going to become a theorist. The labs in this module were also far more interesting. They were entirely computational, which was good because we'd been taught some Python in first semester by the maths department, which gave us a bit more of a skill set for looking at this stuff through Python, looking at real data in these Python labs for astrophysics. What I really liked about these was you got to get hands-on. As a second year Astro student, you're getting hands-on with real telescope data and getting really hands-on with the stuff you're learning in lectures, and I think being able to pick that apart is really valuable. These labs really tied in well with the course that we were doing, what we were learning at the minute, or what we'd really just been learning, which I think was just so much better than the physics labs, which tended to be more detached, seen more as a learn more about a new topic that's vaguely related to what you're doing, as opposed to really get into the stuff you're learning in lectures. And I much preferred that. And I much preferred what we did in Astro, where we were digging into stuff we'd just been learning. The only real downside with labs is that because this was a second semester module, our exoplanets lab got cancelled because we moved home due to COVID. And as much as the school was really good at getting lectures and tutorials online, it was going to take a bit more effort to get the lab parts of the course online as well. On the whole, I really enjoyed this module. It would have been a little bit better if COVID hadn't screwed over the end of it. But this module is what convinced me an astrophysics degree was what I wanted to do. I really enjoyed it, and it was very much right. Astrophysics was very much for me. Second year, on the whole, good grounding for future years. There were some issues, like a couple of lectures that I didn't really gel with, and the overly maths-styled lectures, and, you know, on the whole, it was good, aside from the whole pandemic thing, which I will get onto later. Like I said, second year was a really good basis for third year, so that's the perfect jumping off point to talk more about third year. Third year has very limited choice. Most of your choices are made by the degree choice that you make. So for me, astrophysics made a lot of the choices. But before I talk about the astro-specific choices, let's talk about the core physics modules you have to take. Starting off with Quantum Mechanics 1 and 2. These are really well taught modules that I really found interesting, I just wasn't very good at. The quantum mechanics is good, but it's hard to grasp initially. It's a topic that you either get instantly or you don't. And when you don't get it instantly, you don't get it, you don't get it, you don't get it, and then eventually everything clicks into place. And that's what it was for me, but not quite everything was understood, and yeah, I didn't do particularly well, it was just fine. It was taught by Dr. Antje Kunle, who is one of the best lecturers in St Andrews. She's education focused, and there's quite a few of these education focused researchers at St Andrews. Their research is in physics education. How do you teach this stuff? And it really shows. Antje is one of the best lecturers I've ever had. I've had her for a few modules, and she's great. She developed visual tools for these modules for QM1 and QM2 that really help you grasp some of these concepts, because quantum mechanics is difficult to visualize. It's not like astronomy where you can, point a telescope at it and say, look, this is what we're talking about. QM1 was very much learn the topic, learn the different scenarios we're talking about, learn why things happen. QM2 was somewhat easier. It was an applications module, really. We didn't learn that much new quantum mechanics. It was mostly take the stuff you've learned in first semester in QM1 and apply it to stuff, apply it to different scenarios, different experimental setups, and try and understand them. I found QM2 much more interesting because it was, again, taking the stuff we'd figured out in first semester and then applying it. QM modules also used a system called Peerwise, which was an interesting one. It formed part of our grade, and what you had to do was come up with, you came up with your own questions and then answered other people's questions, and you had to reach a certain, combined score of answering and asking questions to get all the credit in the module. It was interesting, it was quite time consuming, but I do think it was good, because one of the things that people say is if you want to fully understand something, then you've got to try and teach it. And asking questions about something is one of those things. If you've got to formulate a question, you've got to understand it well enough to get the right answer. And it was multiple choice, so you had to be able to say, this is the answer, this is one of the answers, and then give 3 answers that would be similar enough to maybe trip people up. It was good, it was an interesting way of looking at things, but I am glad it wasn't in every module because it was a bit time consuming. Moving on from quantum mechanics, let's talk about thermal and statistical physics. So this is talking about bulk thermal properties, and then also talking about like individual atoms like boson, fermions, different particles, stuff like that. It was simple enough, but it's not the most engaging thing. I didn't love it, so I kind of didn't try as hard, and I probably could have done better in the exam if I had. It's not a bad module, it's just not that interesting. I'm not the biggest fan of thermal physics. I find the way it's taught a little bit irritating. It's always taught rather abstractly, and that was the way this module was taught. I would much rather have like real systems, talk about a bit more of the complexity rather than, so we're going to have an adiabatic and isothermal system. That's not real. Tell me about something that's real, and then we can start looking at this. This was my problem with it, is fair enough to teach the abstract stuff, but like actually tell us a bit more about it. So thermal and statistical physics, not awful, just not my favorite. I want to talk about another module that was not my favorite, in fact, was my least favorite for the entire year, and possibly the degree, not quite the entire degree, is computational physics. This module is a good idea in principle, but it is fatally flawed in how it is taught. The idea that you can just point folk in the right direction with a new coding language and say, do these assessed questions every week, and assume they'll learn to code in the process, is utterly ridiculous. This module has been the bane of many physics students' existence for a while, and I think fundamentally it's that the school doesn't really get the problems with it, despite the fact they've been taught. Also, a timed coding exam can get in the bin. Like, that's not an exam. That doesn't test your ability to code. That tests your ability to not get a bug the first time that you can't find. Like, you know the number of bugs you get in code that's like you're missing brackets or a comma or a semicolon? That's just, it's not any good. I don't like it. So yeah, coding exams can get in the bin, and this module is just, it has its flaws. I had to do it in a programming language called Mathematica, which also get in the bin. It's only really used by people doing like theoretical physics or a bit of maths because it can do symbolic integration. It has now been changed to Python, but now it's all the same problems in Python. You're not taught how to do the stuff. You're just kind of given some vague instructions and told to do these assessed questions every week. I think the module could be really good. It's just not done very well. A module that is done really well, however, is Maths for Physicists, one I said I would talk about a little bit ago. It's taught by this guy called Chris Hooley, who is a really nice guy and a brilliant lecturer. This module is what I wish the second year maths modules had been like. The way that this module was taught gave meaningful examples. It wasn't an abstract case of a vector field. We were talking about like point particles, we're talking about magnetic fields, and looking at like how you're using these various vector calculus things and other mathematical techniques. And it's what I prefer as a physicist, seeing the actual use of the piece of maths you're using, rather than the idealized situation that you can use it for, but you never really would. The module was really well paced. It wasn't so fast that you couldn't keep up. It also wasn't so slow that it got bogged down with too many examples. I found it brilliant, and honestly, I wish the second year maths modules were like this. It's that good. The final core physics module that everyone has to take is Electromagnetism. So this is looking at sort of the Maxwell's equations of electromagnetism. They're a core of all physics. Using a bit of vector calculus, you're understanding how things move and why, light, electricity, electrostatics, magnetism, how all these things work. And I did not enjoy this module. Again, it's lecturer that I don't like his style of lecturing. It's never really gelled for me. I did well in the exam. I have no idea how. Honestly, I don't understand. I got the biggest shock when the grade came back and it was good. It's been useful. It's a useful area of physics to know. You need to know it for going into anything later on. But yeah, great for magnetofluids later on, just not really the best module for me. I just didn't like it. What I did like were the Astro modules in this year. One of these modules is Extragalactic Astronomy, which is actually a fourth year module that we take in third year. It's a really good module. It's a bit confusing at times with some of the cosmology, but it's got a really good lab component. You're digging into real data and doing it more as a sort of scientific exploration rather than sort of more following instructions. The module was really well taught. It was taught by two lecturers, Rita Tahiro and Keith Horn, and they went into really good detail, and they were always there to answer questions on these topics. And this module was really on the cutting edge of science. This happens later into degrees. There was actually, I remember there was a slide that was, it was like, we'd built up to this slide, and then it just said, active area of research, we don't have the answer yet, or something to that effect. And honestly, I'm like, this is what I'm here for. Being able to do stuff in universities that is really on the cutting edge, where we don't know the answers, is it's honestly just amazing. It was also our first chance to really use Python without our hands being held all the way through like we had in second year. And we had another bit of coursework that wasn't assessed. It was a non-assessed class test. This is amazing. I wish other modules had this, along with other continuous assessments. I'm not saying 100% exam is the way, it really isn't. We used this class test to gauge our own progress. We did the class test under exam conditions and then marked it, got the marks back, and we could see where we were struggling, where we weren't. And honestly, can other modules please have this? The idea of using a test rather than stressing you out, but to gauge your own progress in the module is wonderful. I want to see this elsewhere. I'm really sad I didn't see it elsewhere. The penultimate module from third year is another Astro module. It is my favourite module of the entire degree, Computational Astrophysics. This is the module that CompPhys should have been. CompPhys should really take note on this. In this module, we're taught how to use a programming language called Fortran. It's a low-level programming language, not too dissimilar from the likes of C and C++. There were three main sections of this module. The first task was learning the basics of the language, how to construct subroutines, how to do stuff with this language, because this language doesn't have built-in functions. Everything is very, very basic, and you build stuff up, you build your subroutines. The advantage with this is it is very, very fast, much faster than Python could be in its wildest dreams. The second task was a numerical integration task. How do we build subroutines upon subroutines and find an approximation to a mathematical problem? And then the final one was a more complicated project where we're doing numerical integrations of orbital systems, solving a system of ordinary differential equations numerically using Fortran and writing all this code ourselves. The module was set up brilliantly. It was set up to let us learn together. We spent a bit of time learning about the basics of the course, basics of the programming language, and then we were put into splinter groups, and we had an academic staff member, whether they're a lecturer or a PhD student who's acting as a tutor, there to help us answer questions, help us debug our code, and we were there on Teams, because this was during COVID, to get help and to go through things together to discuss problems. It ramped up in difficulty as we went through, and we had support the entire way rather than constant assessed questions like we had in CompPhys. And because of this module, I really like Fortran. I'm maybe one of the few, but I really like it as a programming language. I went on to use it for a summer project and then again in my master's project, and honestly, I don't think I would be calling myself a computational astrophysicist these days if it wasn't for this module. I really liked it, and CompPhys should take note. It's a bleeding good module. The last module from third year lasted the entire year, and it's called Transferable Skills for Physicists, or as I like to call it, Teaching Physicists to Function in Society. It's a really good module. It teaches us all those skills that we normally lack in the rest of our degree. Some people would call them soft skills. I hate that term. Call them transferable skills. It's just more useful, and soft skills implies that the skills aren't important, and they are. This module gave us the ability to look into resources and research topics, read around them, form a literature review, critically think about technical writing. Why is it being written? What's the bias? What's the goal of it? It gave us the ability to read more broadly scientifically, but also in detail, figuring out what was important and how to distill that knowledge down. There were also presentation parts, which meant that I now feel much more confident giving presentations, and sure, YouTube's helped on this, but this module really helped me get to grips with giving presentations to people based on science rather than just, my whims. The module's great. It's something pretty unique to physics in St Andrews, and it really makes graduates from these programs really competitive in a way that other unis don't, and I think other unis should maybe take note and try and implement something similar. In summary, this year was really heavily impacted by COVID. I spent most of it alone, and this year is meant to be the hardest year in the degree. Despite that, I did enjoy this year. It was a really good basis for the rest of my degree, but in hindsight, I maybe should have spent more time on quantum mechanics and thermo and statistical physics, but you know, hindsight is 2020. This year was a really good basis for the rest of my degree, especially Comp Phys. It was a springboard for doing other modules. For my computational projects, both a summer project and my master's project, it was a springboard into doing a data analysis module in 5th year, which was again very coding based. I think 3rd year really sets up the rest of the degree, the final year or two if you're doing BSc or Masters, really well. My grades did slip a little bit this year, but that's honestly up to the fact that it was COVID and I spent a lot of the year alone, and also the fact that it's a step up into honours, and on the whole it was fine. I was not too upset about the grade slipping a little bit. And transferable skills, really useful, highly rate it as a module. If your university is offering something similar, do it. Moving on from 3rd year into 4th year. This is where things get a lot more specialised and I get to do a lot more astronomy. Two modules on Nebulae and Stars. The first one mostly focusing on nebulae, the second one mostly focusing on stars. These modules were fine, they were interesting, but similarly to quantum mechanics, I wasn't overly good at them. I got on fine, but I didn't do particularly well. I don't know what it was. I kind of struggled to grasp things quickly, and the way the modules were taught were sometimes a little bit, here's all the basics and now we're going to do stuff with them, and I didn't grasp the basics quick enough. I don't know if it was a problem with me or if it was a problem with how the lectures were done, but I don't know, it just didn't quite work for me. Nebulae and Stars 1 wasn't taught brilliantly. This was a fairly common opinion this year. The lecturer just didn't really answer questions in a way that actually made anything clearer. In some ways, I came away from questions understanding less than I had when I'd gone in. Nebulae and Stars 2 was taught better, but I felt there was just maybe too much in there. For a 15 credit module, it's just a little bit too much. Too many topics, not concrete enough explanations on, or time really to digest the material. And I just found it really hard to keep up. These modules maybe sort of pushed me away from working on stellar structure because I didn't enjoy it that much, more towards sort of pre-stellar systems and star formation when I was looking at stuff later on. To that end, let's talk about gravitation and accretion physics. This should have been a brilliant module. It really should have been. The accretion part was wonderful. It was taught by my master's and summer project supervisor. I really enjoyed that bit, and honestly when we got onto this section, I was sitting there thinking, you know, oh yeah, this is why I love astronomy. The gravitation part, however, that was awful. The lecturer could not teach at all. He has since been removed from teaching. He did not explain things properly. Notes may have been from a Wikipedia page that he'd written. Yeah, it was terrible. I kind of want to go and do a similar course elsewhere and get a better understanding of the stuff I really should have understood then. I think our grades may have been slightly adjusted to account for the fact that the lecturer was awful. That was not a great module for the gravitation part. The accretion bit, really good, loved it. Kind of wish I'd had time to audit it again this year. Anyway, moving on to people that can teach, back to Antje Conla and now Dr. Donatella Casatari for atomic, nuclear and particle physics. It was a great module. It goes into the standard model, something that's introduced in like high school, but you don't really have the detailed knowledge to go into in more regard, in more depth until you get to 4th year. It gives you stuff about subatomic particles and looking at why protons and neutrons are different, you know, up quarks, down quarks, all the other quarks, looking at spin and what effect that has on energy level splitting. And honestly, it was really good. Really well designed module, really well structured. Highly recommend it. And you know, if you're doing a physics degree at St Andrews, you have to take it. Another module I really liked was the fluids module taught by Moira Jardin. And yeah, St Andrews has some really great lecturers and you get most of them in your 4th year. It's really good. Moira is one of my favorite lecturers ever. I had her for a 5th year module I'll talk about in a bit. If you want a module that goes through all the key concepts in fluids in a friendly, understandable way, that's a nice pace that couples learning the new topic with really digging into it and understanding it, fluids is the one for you. Honestly, great. At the opposite end of the spectrum from the very friendly approach to fluids is Lagrangian and Hamiltonian dynamics. It's the most theoretical physics module almost that I took at university. Really, it was confusing. The module introduces a load of new mathematical techniques for approaching dynamical systems, things like orbiting systems and that sort of thing. It's the basis of a lot of general relativity and looking at gravitational systems, but it's really hard to get your head around. I really struggled with the module. If it hadn't been required, I would not have taken it. And I don't know if it was just the content or the lecturing style being quite abstract, you know, almost like those second year maths modules. I just didn't really vibe with the module. I didn't really understand it. I understand it a bit better now, but you know, hindsight. It was a real challenge and not my best module by a long shot. I vibed more with Intro to Condensed Matter, which was an optional module that I took. I had an empty slot. This was again taught by Chris Hooley. It's an interesting module. It falls into the category of like quantum mechanics of really interesting, but I wasn't overly good at it. Again, I didn't grasp the basics fast enough. Once I got them, I caught up quite a bit, but it made it a bit difficult for me because, you know, not understanding the basics makes understanding the more complicated stuff a bit harder. I felt like I'd been left behind a little bit by the course because I didn't get the stuff right at the beginning quickly enough. It came out okay. Not my best module, by a long shot, not my worst. But yeah, I liked Intro to Condensed Matter, but I was, you know, well convinced that I wasn't going to go any further with that area of physics. And then the complete other end of the spectrum from Intro to Condensed Matter is Observational Astronomy, a module I was really good at, but I didn't really enjoy. This module dealt with real observational data, first looking at exoplanets using real data from the Transiting Exoplanet Survey Satellite, or TESS, and then picking apart star-forming regions later in this module with new images from the Las Cumbres Observatory and with data from satellites like Gaia. We did a lot of analysis using Python code and some specialist softwares for astronomy, and then we wrote up our results in sort of mini scientific papers. It was really good, really interesting, and I was good at that. My writing was praised as being very clear, very succinct, and explaining what I'd done and why, and you know, I did pretty well. But I didn't enjoy it. I didn't like dealing with observational data. It was really messy and noisy, and it just, I don't know, it wasn't really for me. It really cemented for me that being an observer is not what I want to do. I want to go and do theoretical astrophysics, do computational stuff. I want to be able to reproduce observations, but not to have to deal with the observation stuff in the first place. It's too messy, it's too chaotic. I want nice, clean simulations. But this is a review. The module was really good, it's just not really what I find most interesting. So in summary, fourth year was when I really started to feel like an astrophysicist. Started to figure out what I liked, what I really didn't like, and what I wanted to do going forward into my final year. Also during this year, I was school president for the School of Physics and Astronomy, something I will talk about in a bit more detail later. I think it meant that I didn't perform as well academically as I could have, but I'll come on to later the trade-offs that came along with that. On the whole, little in this year stands out as being amazing, except the fluids module, and little stands out as being horrible, except, you know, the gravitational part of gravitation and accretion. The rest of the year was just a bit meh. It was fine, it wasn't amazing, it wasn't awful. It was very much setting up for a really good final year. Speaking of that final year, my fifth year was probably the most independent. I did 4 modules in my first semester, and then my entire final semester was based on the master's project. In my first semester, I took an advanced data analysis module. It's great. I didn't expect it to be, but I really enjoyed it, and it's been possibly one of the most useful modules for me. It was about learning to write code for data analysis, and doing analysis on real data and understanding why you would do certain different analyses for this. We were dealing with real data, learning the right ways and the wrong ways to manipulate scientific data. It was also probably one of the most useful modules that I took while at university, because it meant that I had data analysis code that I'd written, that I fully understood, and that could form the backbone of my analysis for my master's project. I used a lot of the code I wrote here for running actual analysis on my simulation data later in my degree, and honestly saved me so much time going forwards. At times the module was a little bit confusing, the lecture wasn't always the clearest, but I don't think that overall detracted from it being a really good and really useful module. Another good module from my final year was Applications of Quantum Physics. It was really good. It was taught by Donatella Casatari, who we'd had for atomic, nuclear and particle physics, and it was about applying the concepts that we'd learned about in QM1, QM2 and atomic, nuclear and particle physics to real systems. It was really interesting, but I do have my criticisms. The module was really slow. I honestly think there maybe just wasn't enough in there to constitute a 5th year level module. The only reason I see this as being a 5th year level module is because you had to understand a lot of the stuff that's learned earlier in the degree to be able to do this. It could really have been a 4th year module. It just happens to be that where atomic, nuclear and particle physics is in the degree, it needs to be later. My other criticism with this module, and it's not honestly to be fair anything to do with the module, is that it's not anything to do with astronomy. There is a lack of astronomy content at 5th year level in St Andrews at the minute. It forced me to pick a quantum physics module because there just wasn't enough Astro modules that weren't really coursework heavy. Let's talk about the other Astro module I took, which was Magnetofluids. Taught by Moira Jardin. Honestly, it was great, but it was a bit challenging. Magnetofluids are fluids that interact with magnetic fields, so we're looking at solar flares, we're looking at star formation, we're looking at all that sort of stuff. I found it a little difficult to grasp some of these concepts. Magnetic fields are something that I have a little bit of difficulty fully understanding, just because they're a bit more tricky. They're not simple fields like gravity, for example. We're ignoring the fact that gravity is an unsettled question and we don't fully understand it, but you know, it's not like electrostatics, it's a bit different, everything's at weird angles. That being said, as much as it was difficult to grasp initially, the module was set up really well. We had whole class tutorials, which initially doesn't sound great, but there was maybe 15 of us at most. These were really helpful. We got so much one-to-one time with Moira, being able to ask questions about the course, but also tangentially stuff that was related to it, sort of understanding more about astronomy and how this fits into it. And honestly, that was great. While it was hard and this module took a lot of work, I still rate it. It's a really good module, and I think if you're interested in astronomy and magnetic fields and fluid mechanics and stuff like that, and you're at a 5th year level in St Andrews, or you're doing one of the top masters courses, it's really good. You should take this module. And that leads us on to our final top module of the entire degree, which was General Relativity. This was the biggest mistake I ever made at university, was taking this module. This trumped sleeping through the damn class test in first year. This module nearly cost me my degree classification. It really shouldn't have. General Relativity is hard. I knew this going in. Conceptually, it's quite easy, but mathematically, it's quite difficult. And the lecturer on this course was not really able to explain the maths to people who didn't have a really in-depth math background, and that included me. He also didn't really answer questions. If somebody asked a question, he would say, go do the question in the homework and you'll understand it. I couldn't do the questions in the homework and then didn't get answers to questions in the lectures. I really tried, but we just didn't get the support we needed in this module. There were so few questions asked in the lectures because we didn't understand enough to ask them in the first place. I didn't really understand what I didn't understand well enough to ask questions to understand it better. This module was really hard work, and I honestly don't really know how I passed it. I'm amazed. It's probably the only module I took in my entire degree that I would actively recommend people don't take. That brings us to the end of the top modules of my degree, and on to the final semester of my entire integrated master's degree at the University of St Andrews. My master's project. 60 credits the entire final semester. I covered my project fairly extensively in the series about it. You can find that playlist in the top right hand corner of the screen just now. Let's have an overview. The way that projects normally work in the School of Physics and Astronomy in St Andrews is that supervisors come up with projects, they're submitted onto a list, and then students select preferences, they rank them 1 to 6, and you're given a project based on your preferences, and most people get their first or second preference. I took a different route. I'd been lucky enough to attend the National Astronomy meeting virtually in 2022. And at this, I'd seen dozens of talks on a variety of topics, and one of these led me to a paper, which led me to another, and then another, until I found a paper by Seppi and collaborators about hierarchical triple systems that are accreting, so taking mass from a gas cloud onto the stars. I spoke to the supervisor that I'd had for my summer project and said, this looks really interesting, can we do something in this area? And we came up with a project. It happened to be looking at accretion of mass and angular momentum on these triple systems, looking at changing the mass ratio, so a little bit different than what that existing paper had done. This project got confirmed for me before the ballot had even come out. The project was submitted and that's what I was going to do. I didn't have to hope to get lucky enough to get my first choice project. This gave me a somewhat unique experience of doing the project because it meant that I was doing something really interesting, something I was passionate about right from the get-go. It was really gratifying, and I really enjoyed doing research. I liked picking apart a new problem that we don't know the answer to yet and trying to get there. My experience of doing it was really good. I had some amazing supervisors who I cannot thank enough. They had exactly the right amount of support for me. So they let me try things, they let me hit my head against a brick wall a little bit until I asked for help, and were then able to help both with the computational side, because it was a simulations project, as well as with the physics side, understanding what was going on, because, you know, they're far more experienced in this than I am. And honestly, the supervisors made the whole project. I think if I hadn't had good supervisors, I would probably look back on this project less fondly. If you want to know more about the project, then go watch those videos. I'm not going to dwell longer on this because I've made many videos on this already, and I think you should go and look at them instead. So to summarize my final year, it was fundamentally different from the rest of my degree. There was a lot more independent work, there was a lot more specialist modules, a lot more specialist work, and a lot more opportunity to work directly with academic staff. Because the year has halved in size, going from the BSc 4th year to the Master's 5th year, the lectures have so much more time for individual students. More opportunity to discuss work directly relating to the module, but also other science as well. This year wasn't without its issues. General relativity was a huge mistake, and honestly, I wish I could go back and, not do it. I was warned and I took it anyway. It was my own mistake. As much as I enjoyed the project though, there was something a little isolating about the way that the year was set up to have it be the entirety of the final semester. Because I was doing a computational project and a lot of my friends were doing similar ones because we were all doing astronomy and a lot of it's computation based, it meant that it was far easier to do my project from my flat than from a laptop in the physics building, which meant I didn't see that many people during my final semester as much as I would have. I compensated a bit with the social side of uni, but I think there's maybe something to be gained by at least having a room set aside for 5th years to do their projects or something like that. I don't know. I don't know if it would have been better if I hadn't got into these habits of working from home during the pandemic. Fundamentally though, this was still a good year. The social side helped a lot, and honestly, 5th year stands out as one of the best ones. The other thing with being a 5th year is that you are the oldest year in the uni. Fundamentally, very few degrees have 5-year courses. As the undergrad population goes, if you're doing an integrated master's degree, at some point, you will be the oldest. And you know what? In some ways it's good. You know everything that's going on, you know what's there, but in some ways it's bad. A lot of people have left. It's a shame because you see everyone graduate, the majority of the people that you know in your year, and yeah, it's different with people gone. And along with being the oldest in the university, you're also dealing with the fact that you're studying at a very high level, and it's the first time you don't have people in the year above that you're friends with that you can say, oh, do you mind giving me a little bit of a hand with this? It's much harder to get support when you're all learning something new and there's nobody who's done it before to ask other than the staff. So that's a bit of a change as well. And then you're also just fundamentally aware that it's all coming to an end soon. And it's very odd getting to the end of your degree because you work really hard and you get to the end of your assessments, you hand everything in, and then it's just done. And then you're in this sort of waiting game. You see people leave that you're friends with who aren't staying for graduation because they're in other years, and you're aware you're probably not going to see a lot of them again. And then you get around to graduation, it's this big final thing, and it's very odd because you wander around St Andrews and you realise that, oh, this is the last time I'm going to go and see this person at their flat, or it's the last time you're going to walk down this particular street, or it's the last time you're going to that society's events. It's very odd, and you have to try quite hard not to slip into melancholy. But I think that's a thing that happens irrespective of what university you're at. But it's something that I don't think I fully expected. I don't know, maybe just because I hadn't thought about it. So that wraps up that very long year-by-year look at everything in the academics of the university. Now we're going to look more at the social side, the extracurricular stuff that happened outside of the classroom. Something you need to understand about St Andrews is it is small. The students make up about a third of the town. It takes me about half an hour to do a lap of the town on my bike, and I am not that fast a cyclist. Because of this, it doesn't have a lot of the attractions that cities have. Most of the things you're going to do as a student there are run by students. It's self-made fun, it's student run, and there's nothing quite like it, to be honest. My extracurriculars focused on 4 things in my time at St Andrews. The Celtic Society, where I did Scottish country dancing, the Astronomical Society, which is a hot chocolate society in disguise, the University Wind Band, which is an unauditioned group where we do a mix of like wind band pieces, but also like stuff from films, video games, and TV shows, and then doing some academic representation. Let's go through these in order of minimum time up to maximum time. So AstroSoc, I was just a member. I didn't get involved in running it, but in my first couple of years, I was going along every week, and I was even signed up to go on their trip to Prague, which then got cancelled because of COVID. Good laugh. good fun, but I stopped going as much later in my degree, partially because I got out of the habit because of COVID, and then some of my friends ended up running it, so didn't have as much time for chatting as they'd had in previous years. Just wasn't quite as fun, and I knew fewer people because people graduated. Just kind of the nature of things. I stopped going to AstroSoc quite as much. I went a couple of times in my 5th year. That was about it. Wind band. This was something that happened for me right at the start of uni. I went along to wind band with my tenor horn, which is like a mini tuba. It's an E flat horn, so it's French horn parts up a tone. And honestly, wind band was great. Really social, really fun. I really enjoyed it. I thought I might do more music at university than I had, but oh well, it was still really good fun. We did 2 concerts a year, and if you want to have a look at any of them, the links to a playlist of videos that I recorded for the university wind band is in the description below. Go have a look at them. They're good fun, and I look back on them really fondly. I think this is the society that I really noticed the fact that I was older than everybody else in the undergrad population, because a lot of my friends obviously left at the end of 4th year, and the character of the band shifted. For my first few years, the brass section had really dominated the social side of it. It was really lively, really outgoing, and then later on it sort of shifted to being more woodwind, and it wasn't let's go to the pub, it was oh let's have a movie night or whatever. It was, I don't know, it changed, and societies do that, and when bands do that, they change over time. And I realise this sounds a little bit like Old Man Shouts at Cloud, but it was the first sort of, I don't know, maybe the first sort of hallmark of I'm getting ready to move on from St Andrews. And I don't know how I feel about that, but wind band was good fun, and I really enjoyed playing with it, and I hope that I'll be able to find something similar I've left uni. Next up is academic representation. This isn't a society, it is a system that exists in St Andrews and is incredibly well developed. It's a system of student representatives speaking with staff members both in the schools and in the university's main offices to improve how the degrees are taught for the students, how to improve things for people in the schools, and how the university can better support students. I got involved in my 3rd year when I was elected as the junior honours class rep, so the 3rd year rep for astronomy, and I took on the careers rep role as well, so talking about how the school does career support. And then after that, I went on to be the school president, so coordinating all academic representation, chairing the student staff council, sitting on the education committee at the students' union, and having conversations with higher ups in the university like the proctor and even the principal. And this was something that I honestly really value. I think that being school president meant that I gained a lot more skills that I otherwise wouldn't have. I'm definitely more organized than I was when I started it. I'm much better at articulating my thoughts to people and convincing them of things. And it gave me an insight into how the university works and how a university department works, and how you can make progress in ways that people never see. That part of making progress is telling people that the progress has been made and why and how. It's something that I think more people should get involved with, because it gives you, yes, it gives you the CV boost, but it gives you a load of skills going forwards that just builds on the transferable skills from the physics degree. So if you have an academic representation thing at your university, get involved in it. It's really good to be involved in this stuff because you learn so much and you meet people from across the university, which is always useful. Different perspectives normally add to the overall experience. The final extracurricular is possibly no surprise to people that have been following for a long time, and that is the Celtic Society. This is the oldest society in the university. I was on the committee from about week 4. I did Scottish country dancing with them from the start of university right through to the end. I served as their president for 3 years. I taught dance classes in my final year, and honestly, it made my time at St Andrews. 2 dance classes a week, and also leading the committee as they set up more Gaelic classes, Scottish Gaelic language classes. I didn't really do them after COVID, but they kept going and they're still going. And honestly, Celtic Soc, it's going to hold such a place in my heart forever. I look forward to going back to their Highland Ball next year and every other year after, hopefully. It's given me a hobby for life, and I don't really think that I understood quite how much it was going to mean to me when I signed up initially. If you're going to go to St Andrews, go and say hi to Celtic Soc. They're really good. They do Cayleys, they do Scottish country dancing, they do Scottish Gaelic. Tell them I said hi. being Celtic Soc president was one of the best things I did at university. I got to be in charge of a society that did so much. Honestly, it felt less about running the society and more about taking care of it. A society that's over 225 years old is something to be taken care of, something to be respected, and something to be improved upon, because you want it to be there for another 225 years, and you also never want to be the president that lets it die. I can't say thank you enough to everyone who was involved in Celtic from the start right through to the end. Everyone who was on a committee, everyone who came to a dance class, a Gaelic class, and who made my experiences at Celtic such a highlight of my time at university. I can only hope that anyone else who goes to Celtic Society or to any other society, any other university, can find a society that means as much to them as Celtic means to me, and that can get that lasting effect from their time at university beyond the academics. So that covers the extracurriculars, and before we summarise everything and wrap up, I want to talk about some of the challenges of St Andrews. It is not a perfect place, and I want to talk a little bit about that. The biggest imperfection with St Andrews has got to be the fact that it's bloody expensive, particularly around accommodation. To give you a bit of a sense of how bad this has gotten in the last few years, let's look at the fees for university halls. Specifically, University Hall, a standard catered hall of residence at the University of St Andrews. So standard catered means you have a shared bathroom, you have a room to yourself, and you have meals provided to you, with the exception of dinner on the weekends. In my first year, this cost £6,600 or thereabout. Already well beyond a Scottish student loan. The same room, with the same catering and bathroom arrangements, now costs £8,300. It's increased by £1,700 in 5 years. Compared to inflation, this is an extra £700. Inflation has been insane at the minute, by the way. Private rents have also gone up. I don't have a concrete number for this, but to give you some anecdotal evidence, my third year flat, so this was in 2020, it cost £500 per person per month, and this was considered cheap for St Andrews. In town, it was common to see £700 per person or higher in 2020. Now we're seeing well over £900 per person per month, commonly in town. Why? Well, the uni side, I can't fully reason, because their expenses cannot be going up that much. No one is happy about this. The private rental market, it's a combination of a lot of factors. First off, the university closed Albany Park. This was a large and cheap hall of residence. When I moved in, it was about £3,500 for the year, standard self-catered. So food wasn't provided. It was a big accommodation complex near the East Sands beach. It has still not been replaced 5 years later. The uni and the council are disagreeing about what it should be. The uni wants something quite luxury, the council wants them to build something affordable, same as everyone else. Since the closure of Albany Park, the cheapest rooms in St Andrews have been around about £5,000 or £6,000 per year. This already exceeds the Scottish minimum loan, so by proxy, only people that can afford to pay this are going to be in St Andrews in the first place. This means the private rents will increase, because they think, oh, if they're going to pay that much for the halls, they're going to pay that much for a private flat. The reduction in university rooms has also put a massive strain on the housing market in St Andrews. Prices went up further. The council has a ban on new housing and multiple occupation licenses, HMO licenses. So this prevents any new properties bought up to rent from being rented to more than 2 students. In theory, this was meant to mean that families could get houses in St Andrews. In practice, it means that 3-bed houses are being rented with a spare room, because the rental prices have got to the point you can buy a house and rent it to 2 students and still be turning a profit. Then COVID came along and the whole exam fiasco happened, so there was a massive increase in students. An extra 2,000 students go to St Andrews compared to when I started in 2018. This is a 25% increase. So this is only putting more strain on the housing market, pushing up prices and making it more elitist, quite frankly. People have been pushed into Dundee or into the villages around St Andrews, something that was practically unheard of before. Accommodation in St Andrews is expensive, and I don't see it getting much better anytime soon. I can only hope that Albany Park is replaced soon and it's replaced with something affordable. And I mean, the council isn't doing much to make it better. They've allowed another 15 HMO licenses to be granted in St Andrews. Even if all of them go to 5-bedroom houses, which they won't, that's still only another 75 beds available for students. That's not enough. And obviously, if we're talking about challenges and I'm talking about my time at St Andrews, I can't talk about the whole time without talking about COVID. The COVID-19 pandemic was a major disruption to all of our lives. In particular, it had a huge impact on my degree. COVID sent me home from uni in the second semester of my second year. It sent me back to this room to do the rest of the second semester, to do all those exams. And then I went back to St Andrews to do my third year semester 1 because I'm asthmatic, my sister was still in school, and it meant that I was safer to be in a flat on my own. Third year was entirely online. My flatmate got to come back up to Scotland in second semester of third year, so I had somebody to live with at that point, but it was still very restricted. In fourth year, things were a bit better. We had a bit more stuff in person, and then in fifth year, things were mostly back to normal. It was mostly a memory because, you know, society kind of decided it wasn't important anymore because we were all vaccinated. The COVID-19 pandemic and the restrictions that came along with it meant that I spent a lot of my degree without the typical support networks that people have in physics degrees at St Andrews, especially during third year, which is considered the hardest year in the St Andrews physics degree. And I do think that this had a bit of an impact because it took time for the community to get back to what it was after we were able to get back into the physics building. It had an impact on the third year transferable skills module. Normally there is a spring conference, we all go up to the Burn House up near Dundee and we get a whole spring conference, and it's normally seen as a really good bonding experience for the year group. And my year didn't have that. We did it online through Teams and then a thing called GatherTown, which let us sort of gather together, but we were all sitting in front of our laptops and it didn't really count. But people say that conference is normally the highlight of their physics degree, and it's something my year never got, and it is something I still wish we'd had. COVID's had some lasting benefits on university though. There's lecture captures now pretty much standard across the board at St Andrews, which is great. It helps so much for people who have disabilities that mean that they can't attend lectures all the time, especially things that flare up, things like fibromyalgia and other chronic pain conditions. It's a godsend for people who have those conditions because you now don't feel obligated to go into uni when you're in pain, and it means you can look back on stuff you didn't fully understand, and it's amazing. And there was one other big benefit that it's the one silver lining I see to COVID, which COVID meant that I had a few more months with my dad. Something that was annoyingly common, far too common during my time at university, was family bereavement. Throughout the course of my degree, I lost my dad and both of my grands. My dad passed away from cancer in the summer of 2020, and had COVID not come along, I would have had a few weeks at the end of uni with him before he passed away. As it happens, I got from March up to sort of early July. And yes, we were shielding. Yeah, the world kind of sucked. We couldn't go out, but it meant we had more time. I wish the pandemic hadn't happened. Everyone wishes the pandemic hadn't happened, but this is something I see as a silver lining because time is precious and you never know quite how long you're going to get with people. I also lost both my grands in the last 5 years. One gran at the end of 2019, the other one more recently. And losing people close to you is not easy. I don't really know what effect it had on my time at university, at my time at St Andrews, but I do know that the people that I met at St Andrews, both in the department who were able to provide a load of support, and also the friends that I made there, made it easier. They checked in that I was doing okay. People at the school, academics in the school, would check in that I was doing okay because they knew this stuff was going on. Friends were there for me when things were tough, and that's because this university is so close-knit, and it would not have been as manageable had I not had those people. So, as much as this is very particular to me, I think just the way St Andrews is, people tend to have really close friendships, and it made all of this a lot easier. So if you were there a little bit, a lot, checked in, sent me a message, thank you so much, because it could have made these last 5 years so much harder than they already were. So thank you. Okay, I'm gonna move on. Let's summarize. In summary overall, academics, did I enjoy my degree at St Andrews? Yes, definitely. Definitely did. It was amazing. There were drawbacks, some lectures I didn't particularly like. There was the whole COVID aspect. But on the whole, the modules were really good. Would I recommend it wholeheartedly? Yes, I recommend this degree. However, I do have to caution you about the aspects of things like accommodation and other things. There are challenges that come along with St Andrews that I would urge you to think about. Talk to people if you're considering going there, going to St Andrews, and really think about, can you afford to live there? Are there other aspects that you're not particularly keen on? If you want to have a look at some of these potential aspects, look at my video, why you shouldn't go to St Andrews. That video is a little bit clickbaity, but there are some good points in there that really you should consider. The social side is what made St Andrews for me. Celtic Soc, academic representation, the wind band at AstroSoc. Honestly, they made my time there, especially Celtic Soc. I've said it loads of times already, but it really did. So I really rate St Andrews. Get involved with stuff, get involved with societies, and enjoy your time if you're going to go there. I can't recommend it highly enough. If I could do it all over again, I would. So what's next? Well, for that, you're going to have to wait. Subscribe, hit the bell icon. I'm going to be releasing a video in the not too distant future talking about what I'm doing next. And I'm looking forward to this next chapter, but you're going to have to find out about that in a future video because this one has been far too long as it is. Subscribe, hit the bell icon. I will see you in the next video. And, go have a look at some of those videos that I have mentioned throughout this one. I'll see you all next time. See ya.